Cool. Okay, so I guess welcome back. We're going to be doing something a little bit different, continuing with this freehand thing that we did yesterday. So again, I'm working on a new algorithm for freehand drawing, and this is how it's going to look. So let me make sure that I'm live here. Good. And I'll post a link to this to Twitter so that folks know that I'm doing this. If you're not following me on Twitter, I'm at SteveReadsOK, and I'm going to be posting more streams now that I have like an office and a setup. Again, and the idea here is that today we're going to be, well, yesterday we were looking at where should we find these points, right? So we don't want to have every single mouse movement create a point, but we do want to create points when we need them, which is around the edges of curves. Basically, is that the more curved a line is, the more points we want. And so what we're doing there is we're essentially, let's see, where's my code editor? I have my notes here. We are essentially looking at each point that comes in, and again we have like a lot of these points, and we are measuring the difference between this segment, the difference in direction, I should say, between like this segment here and this segment here. So we have these 4 points. We'll call them, it should all be just bigger. Yeah. Call them 1, 2, 2, 3, and 4. Let me make these small again. And we want to look at the difference in direction between the segment or the vector between 1 to 2 and 3 to 4. And if it is a if it's perfectly in line, you know, like if these things were just right in line with each other, then we probably don't need to add a point. And so, but if there are a lot of change in direction, then we would want to add a point. But we don't always want to. So we have this like idea of a resource, like, you know, whatever. Let's say it's 32, and if when we look at these things that that resource or these things are perfectly aligned, then we reduce that resource by maybe like 1. If they're very curved, then we reduce it by a lot. We maybe reduce it by all of 32, bring it down to 0. If it's just a little bit change in direction, we reduce it by like 10, right? So bring it down to 22, and then maybe this one's another, 10. And then this one is whatever, 2. And then this one, it's not that big of a curve, but it's enough to bring it down to 0. Once it gets to 0, that's when we say, okay, we want to add a point here, and then we want to restore this back to 32 so that the next time, maybe this is only 1 difference, and now we're down to 31. So every time this resource hits 0, every time that container sort of empties, we create a point, and that's generally the idea of how this thing works. What we want to do in this video is not only do we want to figure out where these points are, but we also want to associate some sort of pressure with each point. So the first thing I'm going to do is I'm going to bump this error amount to like 64, and that's going to make basically fewer points. It's going to compress this line more, and that's going to be helpful for us because we don't want a lot of lines or a lot of points. We want to just be able to see the difference in pressure. Next, what we want to do is calculate that pressure simulation, right? If I was using a device that had pressure, we could actually use I'm using my trackpad on my MacBook. If that were the case, then we could actually use the input pressure, the pressure coming in from my device, like if I was using an Apple Pencil or something. but instead we're going to have to simulate it based on the distance between the points that we add. So, or not even the points that we add, just the points that come in. So that's going to look like this. I have my JavaScript code down here, and I'm going to kind of be translating it up to Rust. So how do we calculate that pressure? First off, where is here, right? So when the mouse is pressed, we have these 4 points that we create, and then as we're dragging it, we kind of cycle them downward. So the fourth one becomes the third one becomes the second, but a fourth one, it's like this. So like shifts one over. And then again, we kind of compare these directions between, this segment and this segment. So we find the tangent of from 0 to 1, and then from 2 to 3, and then we compare we get the dot product of those two vectors. And yes, okay. So here is where we figure out how much we should reduce that resource that I call error. Like error is used sometimes just to describe this container that's going to be reduced. It's probably not the right usage of the word, but that's the idea. But so dot product reduce error by the result, and I'll even leave myself a note here of what we're doing here, which is we are tangent, say 0 to 1 and 2 to 3. And sometimes it's not a number, normally at the very beginning, or if these two numbers happen to be the same, although they should never be the same, but maybe I go forward then come back. In that case, I don't want to continue. I just want to bail here. And what else? We create a result, reduce error, find a point between the previous point and current mouse position. Make this streamlined point new previous point. Pop the temporary point. Add the permanent point, which is this new streamlined point. And yeah, this is, again, you'll watch the other video to see what I mean, but basically we are always adding the current pointer position and rendering the line connecting the current pointer position. And then we are removing it every time as well. So if this last point here is the current pointer position, what happens is we're not sure where exactly this next permanent point is going to be. So rather than adding all of these, points until we find the new permanent point, what we do is we add it, render it, and then on the next frame we remove it, remove that point that we added before, and add the new current mouse position. And so what that does is it just makes sure that while we are finding this new permanent point, the line is still connected to a point underneath the mouse. It's just that that point is moving. And it's hard to tell because, it's like it happens so fast. But if I didn't do that, then it would look like this line was lagging behind the pointer location. rather than like sticking right underneath the cursor. So that's what's happening in the code there. And let's see, what do we need to know in order to get the pressure? I don't think we need to know where the actual permanent point is. We can just, all we really need is these 4 points that are coming up. So basically we just need this information, and it looks like this. Let's do it right here. So we're going to find the pressure, and this pressure is going to be done with like an acceleration. We're going to use acceleration for this. Px, py. Now we need pressure. That's going to be a float. Let's do it down here. Pressure is going to start off at like whatever 125 or 0.125, and then here's where we're going to find the pressure. And it goes like this. Let distance is self.p2.distance to self.p3. We're looking at the distance between, well, p3 is always the current line position, so or like the current cursor position, whether it's not like a permanent point necessarily. In fact, none of these points are actually permanent. This is just, these are updated every time that we move the cursor. So P0, P1, P2, P3 are usually not permanent points. They're just like the last 4 places where the mouse has been. So we want the distance between, I'll actually stick to the numbering here. We want the distance between 2 and 3, and that's the current pointer location. These are like the last 1, 2, 3, 4 places where the mouse has been. And yes, so yes. All right, I'm just going to do this just to point. No, okay, no, distance takes another point. Cool. So it's really just this. Okay, so this is the distance that the pointer has moved in this frame. So between this one and the very last one, unless the last one was the same as the current one, in which case we ignore this completely. So if the mouse has moved, then this is the distance, and this is what's going to run. Then we have this. We have distance divided by 12, and we want this to be min. So whatever's smaller. Does this work in Rust? Okay. And then we have, and I'll be honest, I wrote this before. This is coming from Perfect Freehand. And I used these 2 characters, SP and RP, and I totally forget what they represent. And I've tried to refactor this a whole bunch of times, but I've never been able to remember exactly what. It seems like I should be able to compress this, but in any case, so now we want self.pressure to be self.pressure plus RP minus self.pressure times SP times 0.275. And this is like the rate of change between the pressure. If this is higher, then it changes really quickly. If it's lower, then it changes very slowly. And these are kind of magic numbers, but they are, this is sort of like the, let's call them this, like, minimum distance for pressure. So like, and then const rate of change is, what was it, 0.275. But they are still pretty magic. I think and then let's also do this one. Sensitivity. Not a really good constant. But that is the effect that changing the direction has on the error. And then this is for pressure. Gotcha. Cool. Does that still work? Still works good. Cool. So now we have our pressure, and it's kind of complicated, but it's normally acceleration is like current equals current plus new minus current times 0.5, and that would like average the current plus the new one basically. And so yeah, if it kept on going up, then it would progress that way. If it went down, then it would kind of also progress more slowly, rather than just always jumping to the current value, because the current value is going to change quite a bit, and we want to reduce that noise. Right. So now that we have the pressure, let's do this. Let's make these points. I don't know, how are we going to record this? I guess we could either add a z to our point. Or we could make a new vector of. Could also have pressures be separate from points. I don't like either solution. Let's do this. Let's what do you call it? Line point. Let's have that have a point, and that's a point, and a pressure, and that's float. And then we'll make these a vector, the lines array. So right now it's just a vector of vectors of points, and we'll do a vectors of well, really like point with pressure. I'm not sure if that pressure point. We'll do it that way. And then here, okay, we can leave this empty. It's going to throw warnings when we push this. So really we're doing a.point.x, a.point.y, b.y, like this. And then we do this. It's not a vector of points, it's a vector of pressure points. Pressure point, gotcha. So previous point is still going to be a point, that's fine. A point.x and a.point.y. So really we're just changing our code so that it's so that it uses this new structure, right? So previously these lines were just points. Now they're these structures that include points, and current point. So here the current point is not going to just be this. It's going to be say pressure point. If I do this pressure point, point is going to be the current point. Pressure is going to be self-net pressure. So this is the first point. And then do this. That's good. Then down here where we push the kind of the current point, again, it's not going to be the current point. It's going to be this, yeah, pressure point. this is still going to be right. Pressure, self.pressure. Yeah. Let's make a current pressure point rather than repeating ourselves too many times. So once we have the pressure, we can say, yeah, current pressure point equals pressure point with the point, the current point, and the current pressure. And we want to do that here. I don't think we can do it down here because it's in a different scope. We'll just have to do it manually or repeat it. Okay. I think that's actually going to work. I'm not sure if there's anything that we're still missing, but let's see if the code at least runs. No. Value used here after move. So that's pressure point up here. Whatever. Let's just repeat it. Line pressure point does not have the copy road here. So I think actually point, yeah, has all these. So we're going to have to do that here as well. So these are like just extra functions that would be implemented. Okay, so far so good. Now we want to represent that those difference in sizes by, yeah, again, having different circles that we draw that represent the pressure. So more pressure, bigger circle. Where's my, yeah, like bigger circle, less pressure, smaller circle. And again, we're figuring out this pressure based on the distance between things. So it's really like if this is close to, well, if there were multiple points, like dense, then it's going to accelerate towards bigness. So it'll be like, oh, this is close, so let's get a little more pressure. This is even, still close, let's get a little bit more pressure. And then as it gets further away, then it's going to slowly taper down like that. And that usually works pretty well with the way that lines are drawn. I should check also the chat in case anyone is watching this. I'm not sure. I think I am streaming, so it should be. Pressure, and then, yeah, cool. I'm not seeing the chat. Normally it shows me the chat and stuff. Oh well, fine by me. Although I really should be able to see the chat. I'm not sure why it's not showing me that. Oh well. Yeah. Very strange indeed. 1 second. Sorry. I might have to just watch this in a different, I'm not sure what tab, and then look down at the chat. Oh yeah, Jonathan, cool. Does the point exist in code and not rendered? No, you know what? I don't really. And he also asked, "Are we trying to replace the freehand JavaScript parts with Rust?" I'm not sure. I'm not sure about the first question. Is the point exist in code and just not rendered? There are these points, like these. Where are we? These 4 points: P0, P1, P2, P3. Those are not rendered. The only ones we render are these vectors, these arrays of lines. These are just used to find the current point. They're like just the 4 last mouse positions. And yeah, they're not actually used. They're never rendered. If I did render them, maybe I should render them just for debugging. let's do that. I'll do that for fun. So that would be olc dot, well, actually, I think what I can do is like self.p0.draw. And I'll do that in olc. Actually, I can do this too. So a.point.draw, and then I'll say that's olc black. Is that right? Yeah, right. I think there should be a draw method on this point, right? I think point has a draw method. Yeah. Why is it not letting me use that? But yeah, the idea is not to replace perfect freehand with Rust. It's more about, well, for me, learning Rust. And, oh, I would have to say some. Strange. Optional parameters in Rust are very, very weird. And then I would say for this, I want this to be red. Draw a line, that's fine. I guess I'm spoiled. So these 4 lines, we'll do that. Maybe we'll do, what is it? Do they have a purple? Magenta, red, orange, yellow. So we'll have a little bit of a rainbow here coming off of our cursor. Okay, not orange. Dark cyan. Dark red. Yeah. So you can see these 4 points are like the last 4 cursor positions. And we're never rendering them exactly. We're just sort of using them to figure out what we should render. Do you see that? It looks pretty cool, right? But a little bit noisy. We're not gonna do that. So anyway, just for debugging. And next, yeah, basically right here, rather than drawing a point right here, I want to draw a circle right here. So, and I want the circle's radius to be based on the pressure for that point. So I want to fill a circle. Let's do that. Fill circle. And I want a.point.x. So I want it to be centered on the centered on the point. And then I want it to be a.pressure as 32 integer. And I want this to be red. And then I still want to draw the point on top of it. Let's try that. Okay, that's not right, because the pressure is probably pretty low. So maybe I'll do eta times, right, because the pressure is going to be normalized between 0 and 1. So I'll make it pretty big. Let's try that. Right. So, and let's get rid of this just to be sure. So as I slow down, you can see the kind of the pressure getting bigger. And as I speed up, the pressure goes down. Let's do that again. So slow, fast, slow, fast. Right. Now, if I really, really wanted to do this just in pure raster, what I could do is, let's do this. Let's do 8 plus this times 8. So a minimum value of 8 plus a maximum value of 16 based on the pressure. That's too much. Let's do 2 plus 8 times I32 or whatever. There we go. Okay, so that's working. We have our pressure and it's modulating pretty well. Now what we want to do is make those lines in between their tangents. And that's going to be also kind of tricky. So let's go back to our pressure point. Let's rename this, not pressure point. We're just going to say node. Because it's going to have kind of a lot of information on it. Yeah. All right, let's just call it node. Okay, so pressure point is now node. And that node has a point, it has a pressure, and it's also going to have well, hold on a second. Maybe we should probably store this in memory, or store this as part of the model. But let's try something else. How are you using the teal draw in a different tab? Yeah, there's a teal draw a VS Code plugin. If you haven't seen this, you should definitely check it out. In teal draw, you can load the plugin, and then you can have teal draw files actually, like from your file system here, and be able to use it in VS Code. It's pretty good. Got to use it. Yeah, 5,000 downloads now. Cool. Right. So yeah, okay. So eventually we're going to come back and we're going to say like, where the tangent points are, like, T0 or T1, etc. For the left side and the right side. But at the moment, we don't actually need that. We're just going to calculate it, however. So to make this easier, I'm going to add some like default points or something like that in the here in like the initial data, so that we can see something and see where it's changing. So node is going to be a point, and then that's going to be at, let's say, 100, 100. That's going to have a pressure of 0.5, 0.5. And then it's going to have, I think it's like this, back. Is that right? Okay, cool. So let's make this 200, 200, and let's just also keep it at 0.5. Then we'll make one more, and then we'll do this is 250 and 150, and let's see what that looks like. Okay, cool. So those are three kind of like node points or whatever. And have my math down here. Just kind of doing a little bit of window management here. All right, so now here are our three initial points. And actually, let's make this a little bit bigger so that there is some difference. And let's also make the radius. Let's make a constant for the radius. Or, yeah, okay. So what I'll say is like min radius. Let's make that big. Let's make that 16. And then max radius is 40. So it's, pressure is going to have quite a lot of, let's make it 32, whatever. And then when we draw this, we're going to do min radius plus pressure times min radius minus, well, max radius minus min radius. And let's actually make that a little smaller, but still have this be pretty big. Okay, cool. And we want to find these lines that connect the circles at their tangents. I don't think that olcPixelGameEngine gives us a way of doing arcs, so we're going to still need to like, let's see, draw arc. No. So we could either do the arcs using lots of little points along the circumference, or just draw the circle and then draw the line behind it. So it wouldn't be, it's not going to make, it's not going to be perfect for what we want to do in terms of just find the points along the outline of this polygon, but it'll get us there. We get us pretty close. So next we need to know how do you find the get circles, say the outer tangents. Where is that? So what is the outer tangent of a circle? Do I have this? Maybe I have this in, I think I have this in a code sandbox somewhere. Let's see. I think it's like geometry or something like that. I know it's in the glob, in globs somewhere. Search on code sandbox is not so good. Let's quickly go through here. No? My drafts? Geometry, curve, mystery spline, state chart. I got everything but what I'm looking for here. Let's undo redo examples. Could be in the isometric thing. If not, I think it is arrowheads. No. Dots, more perfect freehand stuff. I did do this when I was looking at perfect, or like working on perfect freehand, so it should be around here somewhere. Maybe it's in here, maybe it's in here. I just had this like collection of geometry helpers that I was like reusing, and I'm pretty sure that it includes how to get the outer tangents of a circle. Otherwise, I'll just look it up. I don't actually remember off the top of my head. So get circle tangent to point, circle intersection. This looks like it could be Bezier curve segments, all the spline stuff. What are, damn, where is this? Could be in here. Hang on a second. Ah, perfect. Okay, get outer tangents of two circles. So I'll bring this back down here, and then we can just translate this into Rust. Cool. Right, and we'll eventually move this somewhere else, but for now, let's just do it right here. Not super straightforward. We need to find the, and what we're going to do is we're going to find the outer tangents of A and the previous one. So maybe we need to do for I in 1. How do we want to do this? So let's first fill so let's say first is line 0, and we just want to fill this one in always, and then from then on we're going to iterate through that A equals line I minus 1, just as we're we were doing above for the line, for that central line. So we're just going to iterate through. Then B is going to be the current one, and then we're actually just going to fill B to make sure that that still works. So what we're doing here is we are filling the first point, and then starting at the second point, we are filling the second point, but we're also going to get a reference to the point before, and use that to calculate the outer tangents between those two circles, or those 2 points. So first off, does this work? Yes, okay, all 3 lines are still drawn. Now we want to say the angle is a dot point. That angle, do we have angle implemented? Probably not. Let's do that on point. So pub function angle to point. Self other is a reference to a point. And we want this to return probably like a 32-point bit float. We want to do, yeah, does 32 dot, how do you do, maybe Copilot can help me here. Can I turn this on? Interesting. Let me see if I can. Man, I really actually benefited quite a lot from Copilot last time. Let me see if I can reload Copilot. GitHub Copilot, yeah. See if I can disable it and enable it and see if it comes back on. Good, cool. Let's see, what do you got for me? Perfect. That's exactly what I wanted. Good. So we angle to a point, and then let's just do angle to X and Y as well. Cool. Okay. So we want the angle between A, so the point before, and B. I think that's right. Can I borrow a point mutable? Does this have to be mutable? What needs to be mutable? A dot point needs to be mutable? Whatever. Is that? No. This doesn't have to be mutable, does it? See, I wish I could say like maybe mutable. I don't know. It's weird. The thing is that like if you pass a mutable thing to something that just says reference, then it'll complain. Whereas it seems like that doesn't make sense to me. I feel like passing a reference that is not mutable to something that requires it to be mutable seems like that should be, an error. But passing something that is mutable to something that doesn't require it to be mutable seems like that shouldn't produce an error. Maybe it doesn't, but I feel like I've run into that in the past. Okay, so that's our angle between the 2 points. That distance is a dot distance, or a dot point, that distance to point. This should really be distance point. I'm trying to trying to be consistent here in my my API. That means I'd also have to change it down here. And then, right, so A1 is, what was it? It was like F32 to A102. So F32 cosine, good times. We want the radius. So hold on a second. B dot. Okay, we need to know the. We need to know this. Okay, so what is this? A radius is this. Again, we're probably going to have to make this a little bit more into functions, and there's going to be reused code here quite a bit. So we want the difference between the two radii. So A radius minus B radius divided by distance. And then T0 is A radius plus B radius. And then T1 is A radius minus B radius. Right. And now we have our enough to find the 4 points that of those tangents. So that tangent 0 is, it's going to be a point. That's pretty much right. We want the center. Well, let's do this. A dot point dot clone dot add radius A, or A radius times this. Is that right? I think that's right. So that's the X, and that's the Y. And let's draw that tangent 0. Well, see blue? Say blue. Let's try that. That's just the first tangent point. Okay, yeah, that's right. So this to this, this to this, right? And then actually we can just do. Yeah, okay. So let's keep going. Tangent 1 is next. So it's like B radius. That is B dot point dot clone. And then we want to add, we still want to add T1 like this, but we want this to be B radius. Let's try that. Oh, sorry, forgot to draw it. Then tangent 1, I'm going to do a different color. Cyan. Yeah, that's right. or dark blue. Cool. Then we'll use kind of like some other color for the other side, maybe green. And we want tangent 2 and 3. And this time, it's very much the same, except we're going to do T0. And I don't know why I started with T1. It really should be the other way around. And 2, 3, and this we're going to do green and dark green. That seems wrong. T0, sine of T0. T0 is A0 minus, or A radius minus B radius. Wait, hold on a second. Whoops. Oh no, that's right. This is all wrong. A0 is the angle here. Yeah, this is dramatically wrong. Angle plus A1, and this is angle minus A1. There we go, I think, right? I think that's correct. Well, let's try it. We're going to draw some lines. OLC, draw a line from tangent 0.x as I32. And tangent, we could do segment. Like I have a segment. Well, let's just do this. Finish me up. Cool. Is there like a light blue? Or maybe cyan. And then we want one more line on the other side for from 2 to 3. And we want this to be green. There we go. We now have the, that doesn't look completely correct actually. Why not? What am I doing wrong? T1. So first, let me clean this up. This is 2 and 3 should be 0 and 1 because this is they're using T0, T1. These two should be 2 and 3. Right, because these are using T0, this is using T1. I'm drawing the correct lines, I'm drawing the correct dots. That looks good. Instead of doing this in cyan, I'm just going to do it in blue. Right, but this doesn't look like it's like the correct the correct out, like the tangent point doesn't seem like it's correct. Like we are drawing the same. Is it because of its? Do I have to like floor it? Because when we convert it to I32, yeah. Hold on a second. Yeah, that's going to complain down here. Okay. Well, maybe let's do this. Oops. Like what I'm thinking is that maybe the radius is being drawn larger than the because it's being converted to a 32-bit integer. So maybe the tangents are right. It's just that the radius is being drawn wrong. That doesn't even like seem to be the case. Let me make sure that my math is right first before we do anything. A radius minus B radius divided by distance. That seems correct. Distance and the angles, those also seem correct. If the circles are overlapping, they will have potentially no tangents. That's something that the weird edge case that we would have to work out. So we have A1 is cosine of A radius minus B radius divided by distance. That seems right. Angle plus A1. I'm just going to call this A0. A0 plus A1. T1 is A0 minus A1. That's correct. So we have radius 0. The first radius, A radius, times cosine T0 plus... Oh, you know what? You know what I'm missing, I think, is tangent 0. No, that seems right. Yeah, tangent 0, 1. I'm going to do this just to simplify it for myself. The x is going to be a dot point dot x plus this. A dot point dot radius. Cool. So forget about cloning, forget about all that. Just do it just like so. And then I'm just gonna, yeah. So this is tangent 1 is B. That's B radius. But it's still T0. Tangent 2 is A radius, or A dot point, times A dot radius, but times T1. And tangent 3 is B dot point, B radius, and T1. And let's get rid of these. Same result. These look right. This looks wrong. Isn't that strange? It is B dot pressure, right? Like the tangents on the first point seem correct. Tangents on the second point seem wrong. What could that be? I'm going to give it another second, see if I see anything. Otherwise, I think I'm going to give up. Maybe even have to do one of these. Function. What are... This is modern programming here, is asking Copilot to do it for me. I'm gonna see what it comes up with, asking the computer. So I'm gonna describe function and the parameters and see what this comes up with. Tx, bx, py, x1, y1. Very strange. Okay, we have the difference, the delta, we have the distance, and we have, I don't know what A is. That's strange. Very strange. Let's try this. Let's see what that actually produces. But you know, we're on the right right track here. We just aren't all set up. So this would be a dot point dot x, a dot point dot y, radius, or a radius, and then just like that. And then we'll have OLC draw these lines or draw these points. Fill circle, let's say px and py. Give it a radius of 2. Pixel is, we'll see, magenta. Let's see what that looks like. Strange. Okay, that's the midpoint. What about tx and ty? What does tx and ty look like? They don't seem to be anywhere. What about bx? Ty? Nope. So I don't think that this is correct. Maybe circles, outer tangents. We'll try this one more time and then see if we get a good result from Copilot. Say CX1, CY1. Very different solution, a very different approach to the problem. Don't see it. Unless they're like hiding behind those circles, but I don't think they are. One side 32, Y1, side 32. Let's see what happens if we draw a line between those points. Yeah, nothing. I wonder where that is. Oh, it's like right up here in the corner. We have a little magenta dot up here. Pretty similar. If we do this, okay. Well, let's stick with these. They're not perfect. Do have an observable or like observable HQ implementation, but it is also quite a nightmare. Let's see if I can. maybe we can translate this from JavaScript to Rust. Right? Okay. P1 results. No. Okay. L. So we want. Let's forget about results. Let's just draw those points. Fill circle. And instead, what is C? Is that the... Oh, I think these are like the lines. So I think actually this is the only one that we care about. Let's do this. Sorry, this is strange. But we'll see. And let's, what were we using cyan? Then if delta 2 is greater than 0.0, let's do the other thing, but just with those C's. In the observable here, what I often see actually, and this is I would consider this a flaw in observable HQ, is that you have these demos, like, let me pull it up. You have these demos like this, common tangent lines between two circles, wonderful, you have math, and then you have the kind of the visual representation here, which is great. Wonderful. I'm obviously using it right now. It's great. But what happens is the kind of the code is a mix of actually finding the answer and and the rendering, right? So in this case, we have all these lines that are being rendered, and I think that the code here includes all those lines. Maybe that's useful, maybe it's not. But what I often see is that these functions that describe the problem are very involved in the rendering. So they produce a lot more information than is necessary, and it's hard to read. So dogout rend, thank you. This is awesome. But that's just an issue that I've seen. So I would probably want to like carve this up into two different maybe functions or methods. One that describes just like the pure solution to the problem, and the other that is like renders that, produces the visual. So let's see what this looks like. Right, because we are here and we don't have square roots. These seem right. Q is what? Yeah. Square root's going to return. No, hold on. What? Right. No, we don't want. We want this all to be converting to I32. We don't care about the results. The radius can be 4. That looks right. Still nothing. That's very strange. What happens if I don't draw the points in the background? Sorry, we were on a roll here, and then now we're a little bit slowed down. I'm going to not fill these circles. I'm going to try that again. Yeah, they're just not being drawn. Very strange. Because I don't think it's like this. I don't think it's like these points. I'd be surprised if this is really what we're looking for. Maybe. I'm not really reading this in enough detail to make a good choice here. I'm kind of doing this randomly, which is probably not a great idea. What about this? No, nothing. Because maybe it's actually not giving us these points at all. It's just giving the Just these lines. Let me try another way. Yeah, this seems like more like what we were doing before. Okay, we're gonna try one more. We're gonna convert one more JavaScript function, this one from a JS fiddle, to Rust, and we will see if this works. Okay, so if x1 is greater than x2, let temp, oh no, temp equals c1. Ugh. Okay, so they're going to switch these two? Hmm. They're going to modify these. We don't want that. So we, oh, shit. Okay. So we want, um, uh, let's see, x1 equals x1. And we want this to be mutable. Let's see, x2, or cy1 equals y1. Then we'll do these. So rather than using the arguments, we're going to use these internally. Okay, that's the case. Let temp equals temp x equals c1x. Temp y equals c1y. Or cx1, cy1. So we're going to swap these two. And then we want cx2, cx1 to be cx2, cy1 to be cy2. And then we want cx2 to be temp x, cx2. So we're basically just switching the values of these two. Okay. Now we want to get all these things from C1 and C2. That's fine. Maybe to make it easier, let's call these CX, CY. And then let's just call these X1 or X and Y. Okay. Easy. So let gamma is this dot atan. Can I subtract? Why not? Why couldn't you subtract two mutable? What if I did this? All right. Surprisingly, that's fine. Let beta is the asine of this. Good, so far so good. This is the square root. To the power of 2. I don't know how to do that in Rust, so we're going to do it like this. Quickly check back the chat. Don't think there's anything here, but that's fine. Cool. And then, okay, gamma minus beta, alpha, gamma minus beta, theta. Right, so this looks a lot like, what we were doing, up here, right? So like alpha, gamma, beta, whatever. And then Yeah, this looks exactly like what we were doing before. Um, let's see. Let's see what it looks like. I'm going to comment all these things out. And I'm just going to fill the circles. And again, it's not cosine. It's f32 dot pi. I thought there was pi. Hold on a second. Where's pi? Yeah, f6, f32 counts. Oh, maybe it's like this. Standard f32 counts. Okay, whatever. And then we want delta 2. We want the square root of this whole thing. So I need to come back to that. Okay, hang on. So that's the x. The y is this. I'm just going to have to get a towel. And then this is, yeah. Okay, let's see if that 1 point works. Cannot assign twice. I need to dereference x1. It's so strange that I have to, I'm just not used to doing this kind of thing, or using this type of language where we have references. I still don't really understand ownership in Rust at all. Temp y can't assign twice to an immutable variable, but it is. Hmm. Maybe I just don't even. There we go. Okay. Hey, no? No, that's not right. Shit. Hold on a second. Hmm. So I want x1 to be mutable. Can I just dereference just from the start? So is this insane? I make all these mutable, is that better? X2 minus X1. It's so strange. So how do I just make like a, I'm not even sure I understand what's going on. Um, okay, hold on. All right, let's do this. I'm gonna say 0, and I want these all to be mutable. Right. Uh, in that case, x1 is going to be cx2 and cy2, and x2 is going to be cx1, cy1. Otherwise, it's going to be the other way around. I should really learn how to just assign to a constant and solve that. Oh wait, don't give up. Redefine like let x1 equals x2. So close. Okay, hang on a second. Let's go back to where we were. Yeah. This is where we were at, right? You can do that in Rust. Don't give up. Redefine like let x1 equals x2. Huh? Like this? But no, because it's scoped, right? We have someone in the chat is saying how to do this. If x1 is greater than x2, how do I just redefine? How do I just say I'm gonna maybe redefine you like this? Is this how you do it? Yeah, okay. There we go. Right on. Happy times. I'm glad I went back to it. Thanks for the encouragement. Okay, so let's draw our circles again. Now that we actually have a result. That so far so good. And now we want to do the second circle bottom point. That is x2 plus r2 times cosine of, we're still doing alpha, yeah? That looks right. And then we are, let's make these a little bit smaller. Now we want to do the second circle bottom point, first circle top tangent point. And I think these should be the same. It's just using theta rather than alpha. So T1 instead of T0. Let's see if that's right. So T3, x1 plus r1 times cosine. Oh, negative. Oh, that could be it. Maybe I wasn't doing the yeah, I think that was it. I think I was where was my code up here? I think one of these should have been negative something. In any case, I think we have our 4 tangent points. Let's draw those. Let's draw those lines. And again, we're not storing them in memory yet, so we don't have to put these in anything. We just need to draw the points. But let's say, right, tau. This I can put up here because we are going to use this. Okay. Good. All right. So now we have our circles, outer tangents. Who wrote that JS fiddle that just saved me? Eric Sanchi. Thank you very much, Eric Sanchi. Let's get you up on from Nashville, Tennessee. Thank you very much. JS fiddle. Perfect. Cool. Now we have our function to get the, well, draw circle outer tangents. Let's draw them as lines, and just for fun, I'm gonna turn this into a point. So T0 is point new, and then we'll just do it like this. And we don't need these to be 32s. Cool. And then T1, point at new. How do you say the 2 colons in like how do I pronounce that, you know? Like I don't say dot. I think it's something else. Am I doing this right? Yeah. Oh, I think it's actually, is it the sign of the whole? Yeah, okay, no, that's fine. T1. And then it might just be easier to, well, whatever. New. That's T2. And then T3. So now we have our 4 tangent points. After long last. Finally. And we can draw them all. And then we can also draw those lines. So let's just draw them black. And let's also draw lines between them. We could, I think we have segment, right? We have segment in scope. Use segment. Segment. Let's draw some segments. Just that might also come in handy as we kind of move towards Bezier curve segments. By the way, thank you, Genko Levy for saving me there. So that would be S seg1. Seg0 is a new segment. And that, not dot new, segment new, T0, T1. Segment takes a point. Yeah. Then seg0 to draw. That should give us that first line. Yeah. Ooh, interesting that. Oh, no. Okay, that's right. That's right. Let's draw them in blue. That one's blue. And then seg1 is from 2 to 3. Yeah, and like segment like that has a couple of methods that are implemented. And what do? I want this to be like dark yellow. implements methods for like draw, things like that. There we go. Okay. And yeah, you can kind of see as I'm, drawing that we now have a rough polygon that surrounds it. This looks wrong. Some of these actually look wrong. I wonder if I'm using the wrong radius somewhere. Am I passing in the correct radius? B radius, radius, B radius. Maybe that was the issue. No, B dot pressure looks right. Yeah, strange because like, hold on a second. Any of those artifacts like right here? That looks like it's using the wrong. The wrong radius. Maybe we can model that differently. Now, let's see. Does the does the OLC thing do triangles? That would be interesting. Bill, oh, it does do a triangle. So we could do T. What would that look like? T1.x. T. Hold on there. We want to do it like this. T1.x. T2. T0.y. Going to be a lot of as I32s. T1.x. T1.y. So we can kind of start our little mesh here. And then let's do T2.x and T2.y. And then we'll do OLC black. Let's see what that looks like. Yeah. So now we're starting to be able to kind of fill in our line. Let's do red. And then let's also draw a triangle. And then let's do that with black. So we'll do red and then a black outline for the first one, and then red and a black outline for the second one. So here I want to go from T3, and then T2, then to T0, I think. Now there's usually like a rule about how you do that. Yeah, this is not right. So hold on a second. First one's this one. So I think this is like 1, 2, 3. So actually, let's do it. Let's do it clockwise. Let's start. Right. I'm just going to verify that this is. Yeah. Okay. So this is T2, the one on top. So actually, I wanted to. Maybe we'll do counterclockwise, right? T0, T1, T2. So that's counterclockwise. Yeah. Okay. T0, T1, T2. And then on this side, it would be T2, T1, and then T3. Yeah. Okay. So let's do that. T0. What did I say? T2, T1, T3. See, T2, T1, T3. Cool. Now we're starting to get our mesh here. It actually looks pretty good. It's not great, but look, it's like a variable width line. And if we take out all the black outlines and we don't draw the points, then I think we we'll see. So this right now, it should just be the red. It looks pretty good. It's not bad. Right? Variable width line. Let's make it a little bit more noticeable here. And let's bring back the error down to something much smaller so that we can get that. Hopefully we don't get any. Nice. So there are some artifacts that are happening at the change, like I still think that the radius is not being calculated correctly. But that's just pretty good. I mean, like we're not curving anything yet, so these are still straight segments, right? We haven't basically in our progress right here. We're only at this point. We're not at these points. We're just doing straight segments between the curves and drawing those circles between them. But I have to say, this does look a little better than I thought it would. So pretty cool. I think we might have to leave it there, but I wish I could figure out why these artifacts are happening. So maybe we can let's try and fix that. If we can't get there, then we'll give up, which is fine. So I'm not going to draw the segments in between. I'm not going to draw the points, but I am going to draw the meshes because I think that gives us enough to see a little bit of what's going on. First off, we have reduced the resource amount, so we're going to get a lot more segments than we did before. And you can see some of the artifacting here. Let's see if I can, in our, first off, I'm going to move this as a, yeah. Should I move this into somewhere else? Like into a function of up here? Let's do that. So now we'll just call self.render outer tangents right here. And we can get rid of this would be mute self. Cool. Now we can get rid of all of this stuff right here. Except for this. Cool. Does that still work? Good. Okay, so what I'm going to do is go down to here and see if I can replicate that bug. And I'll do it like this. It seemed like it's on these, like, well, how do I? Okay, that did it. I'm trying to see where that happens. This did it. So it looks like it's like either reversed. Is it this weird switching thing? Is this what's happening? Is it not really like reversing it correctly, or was it? Or was it like, yeah, okay, there it is again. Um, it's happening if, looks like it's happening if I'm going to this way. Yeah. Is that even necessary? What happens if what happens if I just don't do that? Looks fine. It looks like it fixed it. So what is this solving? Like why do we need to swap the circles? Because this looks fine. Interesting. All right, well, problem solved. I just don't know. Um, and then we can get rid of this. So all that trouble that I had doesn't seem to be necessary. And then actually, we can get rid of all of this. We don't even need to use CX1 at all. I'm just going to fail it. Like, yeah. Okay. And then let's make sure the drawings go on top. Let's try that again. Not bad. Not bad. And let's do it without the outlines. Nice. Actually, surprisingly, like you would maybe notice it at a higher resolution. The fact that these are straight lines rather than curved segments, but I think that gives us all the information that we need. Next step would just be to do all those Bezier segments that go around the corner. So far so good. Um, yeah, Turner in the chat. This is like such a good setup for playing around with Rust the way that we're doing. Highly recommend it if yeah, if you're into this type of thing. I kind of feel like when we do these changes that we're missing kind of like the sharp corners. By the way, this might be something to go back to um, and figure in here that like if there is a real sharp corner, then maybe instead of doing self.prev.med, we just do self.prev or something like that. Do you know what I mean? Like that the sharpness of the corner should determine whether we like yeah, how much we interpolate between these 2 points. So anyway, we yeah, we'll have to figure that out. But I feel like I'll add it to do because yeah, we are losing those sharp corners. If you want to play around with Rust, this is such a great little setup to do so. I'm quite a big fan of David, or sorry, the One Lone Coder's author, David Barr, I believe. On YouTube, if you haven't seen this, I mean, his content is amazing and has been hugely influential on my own career and my own kind of approach to these types of problems, or just interest in these types of problems. And then, yeah, he's on YouTube. You know, One Lone Coder, huge community of folks working on this type of stuff, and yeah, all sorts of fun problems involving 2D, 3D, and he builds these engines to kind of do these demos. This is the Pixel Game engine, which is normally in C++, but there are Rust bindings that someone made for this, and that's what I'm using here. If you go on github.com/SteveRuizOK, you can find this repo is what I've been working on, the OLC Rust sketches. And this has everything that, yeah, and normally OLC is completely C++, but again, there's Rust bindings for it, so that's what I'm using to learn Rust. And yeah, you could grab this repo, pull it. I think you have to install Xquartz to do the window management, but I think it didn't work until I installed that. And then, yeah, you can just run these examples and see all the code from these streams. So, yeah, I think that should do it for today. I mean, this is already really encouraging, because I want to be able to use this new algorithm to replace perfect freehand in TealDraw 2. It should be somewhere around here. You can kind of see my experiments here. This is the new engine for the next version of TealDraw. So that would be aiming to replace this engine, which is already pretty good, but I think this one does a few things better. And yeah, the issue with perfect freehand currently is that it stores every single input point, and it needs every single input point in order to create this simplified path. We can't just store the image because we want to do things like this. So I have a new algorithm here. You can see there's many fewer points that need to be stored in the data model, and everything still works the same, except this one is not variable width. It's always the same width, right? I just haven't solved that part of the problem. That's what I'm working on here. Decided to try it out in Rust to begin with, because it's a pretty easily scoped problem. And yeah, so far so good. We have a pretty decent variable width mesh line. So we'll come back and next time try and figure out how to do these curves and splines around the edges. So thanks for watching. I'm going to end the stream. Yeah, follow me on Twitter. I'm at SteveRuizOK, and always working on this type of stuff, and usually posting about it on Twitter. So I'll talk to you later. Thanks for watching.